In this example, we'll look at using complex numbers to help us analyze how we can find an upper bound for the radius convergence of a power series. We want to figure out what the radius convergence could be for the power series expansion of this function here, 1 over x minus 4x plus 5 quantity squared, centered at -1. Now the key point that we're going to use here is the fact that if the function does not exist at a certain point, then the power series expansion also cannot converge at that point. What we want to do is figure out at what points does this function not exist, and use those to figure out what the biggest radius could be for this power series expansion. So to figure out where this function is not defined, we're going to look at where the denominator is 0. Well, this happens whenever x squared minus 4x plus 5 equals 0. Because it's a perfect square, I can just take one of those factors and do it this way. Now where is this 0? We'll use a quadratic formula. So it's 0 for x equal to negative b plus or minus the square root of b squared minus 4ac, which is 20, over 2. So 4 plus or minus the square root of minus 4 over 2. Using our complex numbers, this becomes 4 plus or minus 2i over 2, because root minus 4 is root 4 times root minus 1, which is 2i. So we're at 2 plus or minus I as my roots here. These are the 2 points in the complex plane where this function is not defined, where the denominator is 0. So where are these points? Well, plotting them out, 2 plus or minus I are at x coordinate 2 and then y coordinate plus or minus 1. We're looking at something like here and here. Now we're looking for the maximum radius of convergence if the power series is centered at -1. So if it's centered over here, I want to find the biggest disk I can draw that doesn't hit any of these points. And how do we find that? We need to find the distance from the point we care about to each of these 2 points. And this length r will be that radius that we can say we know the radius of convergence is no bigger than this r because it can't converge at these 2 points where the function doesn't exist. Since these 2 points are complex conjugates, the plus or minus I, and the point I'm starting with is on the real line, the distances are the same to those points. Let's figure out what that is. So r should then be the square root of x distance, which is going to be 2 minus -1 squared, plus y distance, which is going to be 1 minus 0 squared, or -1 minus 0 squared, won't matter. So this is going to be the square root of 3 squared plus 1 squared, or the square root of 10. So what this tells me here is that the radius of convergence of this power series can be no more than the square root of 10. In this case, however, since the function is more complicated, it's not just like, a 3 minus x or something, there's no nice way to actually figure out what this power series is centered at -1. However, we can use this complex numbers factor to say the radius will be no more than square root of 10, because at square root of 10 is where I hit the first point where my function doesn't exist, and therefore my power series cannot converge there. Then your answer here is the fact that the largest radius you could get, or an upper bound for this radius, would be square root of 10.